Welcome to this unconventional machining process course, and the course code is ME8073. And this unconventional machining process course is a professional elective 2 for the mechanical engineering students, the regulation 2017. And in this video session, we'll be studying about the unit 3, that is chemical and electrochemical energy-based processes, in which we'll be studying about the introduction to electrochemical energy-based process. So, introduction to electrochemical energy-based process. So, in this electrochemical energy-based process, material is removed from the workpiece by ion displacement of the workpiece material, which is in contact with the chemical solution. And the following are the different examples of this electrochemical energy-based processes. You have electrochemical machining, electrochemical grinding, and electrochemical honing, and electrochemical deburring. So electrochemical machining. So electrochemical machining process normally uses electrical energy in combination with chemical energy in order to remove the material from the workpiece. So this works on the principle of reverse of electroplating. And coming to the principle of electrochemical machining, so this removes material of electrically conductor workpiece, and the workpiece is made of anode of the setup, and the material is removed by anodic dye solution. And you can see from the figure, the workpiece is connected to the anode, and the tool is made of cathode. So here you have the constant feed tool, and that is connected to the cathode of the power supply, and is kept in close proximity to the workpiece. So this tool, the constant feed tool, is kept close proximity to the workpiece, and now the current is passed through the circuit. So both the electrodes are immersed into an electrolyte solution. So electrolyte solution is there, and this both the electrodes are immersed in the electrolyte solution. And normally this works on the basics of Faraday's law of electrolysis. So the cavity machined in is a mirror image of the tool. And the metal removal rate in this process can be calculated by means of this Faraday's law. So coming to the applications of electrochemical machining process, this is used to machine complicated profiles like jet engine blades, turbine blades, and turbine wheels, and used to drill small deep holes in nozzles also. And it is used to machine cavities and holes of irregular shapes. And this electrochemical machining is used to machine blind holes and pockets in forging dies. And hard and heat resistant materials also can be machined. So this also have following advantages. So the metal removal rate in this electrochemical machining is high, and wear and tool tear is negligible, and the low voltage is required for machining, and intricate and complex shapes can also be machined easily, and the surface machined is free of stress, and no cutting forces are involved here. The finish, high surface finish of order 0.2 to 0.8 micron is obtained, and also the tolerance of 0.005 mm can also be obtained by using this electrochemical machining process. And no bursts are produced while performing these operations. And these are all the disadvantages. And The disadvantages for the electrochemical machining are listed as below. So sharp internal corners can't be machined here, and post machining cleaning is required, and complicated tool design. And in order to maintain high tolerance, the control mechanism is required, and you can't machine non-conducting materials, and high initial investment, more space is required, and machining process is comparatively low, and the power consumption, it is normally 100 times more than that of the conventional machining, and proper tooling system designing is very difficult, and you require constant monitoring. And next is electrochemical grinding. So this electrochemical grinding, materials that cannot be easily shaped due to their extreme hardness can be ground using this uh, process. And examples here, you have the cemented carpets and hardened steel. And the principle involved in the electrochemical grinding is, and here the work is machined by the combined action of electrochemical effect and conventional grinding operations. So here this is a schematic view of the electrochemical grinding, and here you can see the wheel which acts as the cathode, that is the grinding wheel, and you have this workpiece which acts as anode. So the positive I mean of this DC supply is given to this workpiece, and the negative is supplied to this brush. And you can see here the electrolyte is being supplied, and this workpiece is placed inside a trough. There is a drain plug here in this trough to drain the electrolyte from the tank. So coming to the application of electrochemical grinding, this is used to machine complicated profiles like jet engine blades, turbine blades, and turbine wheels. Used to drill small deep holes in nozzles, and they used to machine cavities and holes of irregular shapes, and blind holes and pockets in forging dies. It is used to machine hard and heat resistant materials. And the advantages, tool wear is negligible, and work is free of surface cracks and not subject to any structural changes. And it is components that are produced are free from stress and burn. The surface finish obtained is very good, and the surface finish is 0.2 to 0.4 microns, and the accuracy achieved is 0.01 mm, and the intricate parts can be machined without any distortions. So these are all the disadvantages. Initial cost of this equipment is high, and high power consumption is required, and material removal rate is very low, and you can't machine non-conductive materials, and the maintenance cost is high, tolerance achieves is low, and preventive measures are required against the corrosion of this electrolyte. And next is the electrochemical honing. So this electrochemical honing is almost similar to that of electrochemical grinding, and here electrochemical honing uses rotating and reciprocating non-conducting bonded honing stones, and instead of conducting grinding wheel. So electrochemical honing is normally it's a hybrid process in which the material is material removal occurs by the electrochemical dissolution as well as the honing the simultaneously. So the materials removed alternately take place by honing and by electrolytic dissolution. So here are the bonding materials of the honing stone, and should be electrically conductivity. However, conventional honing stones made of electrically non-conducting bonding materials can also be used, and current is passed to the workpiece via electrodes which is mounted between the honing stones. So electrodes are fitted with spacers such as a gap of 0.075 to 0.125 mm is maintained between the electrodes and the workpiece. So coming to the applications of electrochemical honing, and it is used for process, and the process is easily adaptable to cylindrical parts for truing the inside surface and can duplicate over a number of components. So this example which is given here. So 19 mm dia bore of a carburized pinion gear, and it is made of 8620 steel, and hardened to HRC 6062 was honed by ECH, that is electrochemical honing. So 0.05 mm of material was removed from the bore in 4 seconds, and the accuracy was plus or minus 0.002 mm. And the conventional honing required 18 seconds per part and consumed 300% more abrasive. So advantages of electrochemical honing. So increased metal removal rate, particularly on hard materials. And here, since most of the material is removed electrochemically, honing stone life is greatly extended, and burr-free operation. And unlike conventional honing, no micro scratches are left on the workpieces. Less pressure is required between stone and the work, and distortion and noise is reduced when honing thin wall tubes, and cooler action leading to increased accuracy with less material damage. And all ECM-based processes, electrical chemical honing imparts no residual stresses on the workpiece. And by using this, it is capable of achieving surface finish of 0.05 microns and dimensional accuracies of plus or minus 0.012 mm. So the disadvantages: high capital costs and a corrosive environment, high preventive maintenance costs, and non-conductive materials cannot be machined, and requires disposal and filtering of electrolytes. So with this, we come to an end with this video session of the third unit. So thank you and have a great day.